All right, hello, fellow classmates, professors. Um, we decided to do our topic on Parkinson's disease. So now we will begin. I'm Frankie,
I'm Isabel.
I'm Abby.
and let's go.
So, just to get us started on some context, what is Parkinson's disease? So, it's a progressive neurodegenerative disorder, meaning that it does get progressively worse over time. And it's caused by neuron loss in the substantia nigra. And this is a part of the brain that plays a really critical role in dopamine production, and movement control. So, basically, when neurons in this part of the brain die or stop working, a person will experience things like stiffness, a tremor, some of the telltale signs of Parkinson's disease. It's also just important to note that it is the second most common neurodegenerative disease after Alzheimer's. So there's a lot of people out there who do have a Parkinson's diagnosis. And then, unfortunately, there is no cure, but there's a lot of different medications and therapies available to help treat the symptoms. And I'll go into detail on that later. And then finally, Parkinson's is typically staged using the Hone and Yar scale, with stage one being more mild. So things just like a tremor, a clumsy leg, things like that. And then stage five is the most advanced. So people in this stage will be usually wheelchair bound. It's just really important to note that Parkinson's is not a one size fits all disease, because there's so many different genes involved. It really shows up differently for everyone.
So, as Isabel was saying, it's not one size fits all. The cases are really sporadic, and actually having a familial track record of the disease is only about 10%. There are definitely a lot of higher cases in males and females, and more there are more areas that have a higher frequency than others, and scientists are still trying to determine that on why that is. And so every 6 minutes, someone is diagnosed with a disease, and as you can see on the slideshow, the disease is exponentially growing, and we just gotta try and find a cure one day. But only time will tell.
So Parkinson's has a really complex phenotype. So there's a lot of different symptoms, both motor and non-motor. Some of the most common motor symptoms include a tremor, stiffness, bradykinesia, which is slowness in movement, and then swallowing and speech difficulties as well. And then some of the non-motor symptoms, which aren't talked about as much, but just as important to acknowledge, are anxiety, depression, sleep difficulty, memory issues, and then in the more advanced stages, hallucinations and delusions as well. And then the genotype is also very complicated. It has genetic and environmental influences. So there's a really long list of genes known to contribute to Parkinson's. I think it's around 90, and then there's probably still more out there that haven't been discovered yet, because a lot of Parkinson's is still a really big mystery. But the most well-established Parkinson's disease genes include dominant forms, so SINCA and LRRK2. Mutations in SINCA occur in early onset Parkinson's disease, where mutations in LRRK2 are linked to late onset Parkinson's disease. And then there's also recessive forms that include Parkin and PINK1. More than 200 Parkin gene variants have been identified that are associated with Parkinson's, so that's a lot. And then this is the most common genetic mutation that's associated with young onset Parkinson's disease specifically. And then I just plugged in this little graph right here just because it shows how genetic variants for Parkinson's disease differ and how common they are. So rare to common, and then how much they influence the disease. So from a small effect to a really large effect. So rare genes like PINK1 and Parkin have a really big impact, while more common genes like SINCA usually have a smaller effect. I just really feel like this image gives an idea of how many genes are involved in Parkinson's, and then it just shows how each gene will have a different effect and how it shows up.
So the classification of Parkinson's is set to three different types. There's idiopathic, which is the most common, but the cause is unknown, and it mostly affects older individuals. It can be categorized by motor and non-motor, hence the little picture to the left, just to give people another visualization of the effects. Then there's also early onset, which obviously early. it affects the young people from ages from 21 to 40 or 50, depending on the study that the person is doing. It's really similar to idiopathic, however, it progresses slower. Yeah, slower. And then there's also the familial, but again, it's only about 10 to 15% of the times.
Next is specific mutation. So LRRK2, the most common genetic cause of Parkinson's worldwide. The mutation causes overactivity in the LRRK2 protein, which disputes the cell function and damages brain cells. And the second one is Park7, which is the most commonly seen in early onset Parkinson's, so ages before 50. And it causes loss of productive function, and it leads to increased damaged brain cells and areas that control movement. And the last one is Cinca, which is rare but strongly linked to familial Parkinson's. It causes the alpha-synuclein protein to come together and it forms Lewy body, which are key features of Parkinson's. And the next slide is about histology. So Lewy bodies, again, are clumps of protein called alpha-synuclein in the brain cells, and it looks like pink blob with a clear ring around a microscope, and again, it's a key sign of Parkinson's. And the second one is a loss of dopamine neurons, and it happens in the substantia, which controls the movement, and fewer dopamine-producing neurons and loss of darker color in this brain area. And that leads to motor symptoms like tremors. And lastly is reactive glycolysis, which is brain support cells. They become reactive to repair damage, and it shows inflammation in areas affected by Parkinson's.
So this is a pedigree for the gene one, so like familial. Obviously the genes like LARCA, SINCA, and VPS are autosomal dominant. So then that means it's not gonna skip a generation. Once you know someone in your family has it, it's gonna keep going. However, the autosomal recessive, like Perkin, Pink1, and DJ1, um, you might come out lucky, It could skip, well, it will skip, but you still have a chance of getting it. But, as long as you get someone that you know is not a carrier, you might be in luck.
So, moving into the treatments and therapies. So, as a reminder, Parkinson's disease does not have a cure. And a lot of these treatments or therapies are just used to treat the symptoms of Parkinson's disease. So, the most common treatment is levodopa, which is a medication that increases brain dopamine, and this can help reduce tremors and stiffness. And then another one that's common but is a surgical procedure is deep brain stimulation. And this is a procedure that uses electrical pulses to manage motor symptoms. And then a new one is Valev, which was just actually approved by the FDA in October of this year. So that's really exciting. But this is a pump that delivers a steady infusion of levodopa and carbidopa, and this reduces the off times. So just to explain, off times are when medication begins to wear off and symptoms begin to worsen as a result. So a lot of people who are just on levodopa will have these off times and have a lot of worsening symptoms when their medication starts to wear. But this prevents this by giving a steady flow of medication throughout the entire day. So that's a really exciting new treatment. And then there's also focused ultrasound, which is a non-invasive treatment that uses sound waves to target brain areas and can improve tremors and motor control. So this could be a really good alternative for someone who may not be eligible for deep brain stimulation, and it's also non-invasive, so that's really good as well. And then other treatments really important to mention are just dance and music therapy, which can help with both motor and non-motor symptoms. So these therapies can improve balance and mood, and then also just provide an overall sense of community to people in the Parkinson's community. So basically, it's really important to have these in place to reduce some of the non-motor symptoms. So depression, anxiety, those kinds of things. But yeah, there's a lot of other therapies and treatments out there, but I just wanted to highlight a few. And then there's also a lot of really interesting epigenetic influences behind Parkinson's disease, but I'm just going to talk about a couple for the sake of time. So the first one is pesticide exposure. Studies have shown that frequent exposure to pesticide increases the likelihood of getting Parkinson's disease by 2.5 times, which is quite a bit. So if you look at states like Indiana, which have really high agricultural pesticide use, there's really elevated rates of Parkinson's disease in that state. And then there was also different occupational risks involved, which I found to be very interesting. So welders, for example, have exposure to manganese, which can cause neurological symptoms like tremors and mood changes. And then another one was hairdressers, because on a daily basis, they're exposed to different chemicals within like dyes and solvents that they use. So this was also linked to Parkinson's disease. But obviously, a lot more research is needed, but this just highlights some of the epigenetic influences behind the disease as well.
And that's it. Any questions, Professor? Well, too bad your mic's kind of off, so yeah, hit us back up. But yeah, thank you guys so much for coming.
Thank you.
Thank you.